What geological features surprisingly impact groundwater recharge? Imagine water sneaking through cracks and hidden pathways beneath our feet, filling underground reservoirs in ways we might not expect. That's what makes geology so fascinating when it comes to groundwater recharge. You might think only large rivers and rain are involved, but underground features play a big role too. One surprising factor is fractures and faults in rocks. These cracks and breaks create new spaces that weren't part of the original rock structure. They act like underground highways, letting water flow quickly into deeper layers. Sometimes, faults can block water if they are filled with materials that don't let water pass, creating localized zones of high or low recharge. It's a dual effect that can change how much water gets into the ground in different spots. Folds and structural complexity in the earth also influence recharge. When rocks bend and fold due to tectonic forces, they create zones where water can get trapped or diverted. These formations can make some areas more permeable, even if the surface looks solid and impenetrable. So, even in rocky terrains that seem tough to infiltrate, water can find pathways through these folded structures. Topography, or the shape of the land, might seem more surface level, but it impacts recharge a lot. Steep slopes cause water to run off quickly, leaving less time for it to soak into the ground. Flat areas, on the other hand, allow water to linger longer, increasing the chance of infiltration. The geological features that shape the land's surface directly influence how much water recharges the underground aquifers. Beneath the surface, the depth to the water table matters a lot. If the water table is shallow, water doesn't have to travel far, making recharge easier. But if it's deep, water has to move through more soil and rock, which can slow down or limit recharge. Layers of low permeability material like clay can act as barriers, preventing water from reaching the aquifer. The type of rock also makes a difference. Sedimentary rocks like sandstone and gravel have high porosity and permeability, making them excellent at storing and transmitting water. Crystalline rocks like granite have low primary porosity but can still allow water through fractures. Karstified limestone, with its caves and sinkholes, provides rapid recharge routes that are often hidden from view. Lineaments, which are linear surface features, often indicate underlying faults or fractures. These zones tend to be more permeable and serve as natural channels for water to infiltrate deeper underground. Recognizing these features helps in understanding where recharge is most likely to happen. Knowing how these geological features influence groundwater recharge helps us manage water resources better. Mapping fractures and faults can guide where to drill wells for the best recharge. Understanding the land's shape and underground layers helps us predict how much water can be stored. In areas with complex geology, combining geological and hydrological data makes our water models more accurate. In short, features like cracks, faults, folds, rock types, and land shape all work together to control how water moves from the surface into underground reservoirs. These features often have surprising effects, making geology a key part of understanding groundwater systems.